All right. Now, if you watched my last video, this one's going to be very similar. Okay, so we're going to be finding the equation of a tangent to a line from an outside point. In the last one, we found it from the external point of the origin. In this one, it's going to have some other external point, but the process is going to be the same. Now, in the other one, it specifically told us to take an arbitrary point A. In this one, it's not telling us to do that, but that is what we're going to have to do. All right, if you can just imagine for a minute, here's your graph, which then, since it's a cube, looks something like this, right? All right, so external point -2, 0 is right here. So you can picture, if this is it, you can picture one of your things being right here. Now, whether there's another one is, well, I don't know. I don't know that there is going to be another one. I guess if you went all the way down here, you might eventually get, or maybe up here, I don't know, you may be able to get one more tangent somewhere. But let's find out by doing the work. Alright, so here we go. We need to pick some random point A. Okay, so this is A, comma, and then the y value, of course, is just going to be a to the third. Alright, so that's the point that is going to be the initiatory point. That's where we want to take the tangent. We can't use this because the tangent at that point doesn't exist, because that point isn't actually on our line. So that's not the point we want. We want this point a to the third, which we don't know where it is yet. Alright, so the second thing we're going to need is we're going to need the slope. So y prime equals 3x squared. So now we go ahead and we say, well, our equation then is y minus y1 equals m times x minus x1. So we say, okay, that means y minus, now the y value is a to the third, equals the slope, which was 3x squared, times x minus x1. Now, of course, I did say 3x squared, but we are finding the slope at a. And so we do want y minus a cubed equals 3a squared times x minus a. Now, if you wanted, you could simplify from here, but really we're looking for the actual equation, so we're going to need to put in the -2, 0 for x and y. So let's go ahead and do that. We'll go y is 0, x is -2, so 0 minus a cubed equals 3a squared times -2 minus a. So I guess we're going to end up distributing anyway, so we're going to have -a cubed equals -6a squared, and if I distribute this, that would be minus 3a cubed, and maybe move everything over to the left hand side. That would give us 2a cubed plus 6a squared equals 0. If we factor out a 2a squared, that would leave us with a plus 3, and so that would mean that 2a squared equals 0, or a plus 3 equals 0. So we could have a equals 0, or a equals -3. So there we go. That means now then that we have two possibilities when a is 0. So if we put 0 in for a into our equation here, remember this was the equation before we put in this external point to show that we wanted to be able to get the derivative from that specific point. And I totally drew this wrong, didn't I? It should have been -2, 0, which would have given us a couple of different places, which is fine. And then we want to go ahead and use this a equals 0 and a equals -3. So if I make a 0, I'll get y equals, now if I make that 0, that goes away. If I make this 0, then it doesn't really matter what that is. It's going to be 3 times 0, which is 0. 0 times all that will be 0. so y equals 0. The second possibility would be if a is negative 3. So let's go y minus, and then we'll go negative 3 cubed equals 3 times negative 3 squared times x minus negative 3. And so we'll have y plus 27, because negative 3 cubed is negative 27 and minus negative is positive, equals 3 times 9, which is 27, times x plus 3. And so that will end up being y, and then I'll subtract the 27, so equals 27x, and then 27 times 3 minus 27 will be plus 54. And so there you go. There's our two equations. One is y equals 27x plus 54, which should be then the tangent at x equals 3. And then you've got y equals 0, which will be the tangent at x equals 0. And so there you go. There's your two answers for this problem.